How is entropy generated during irreversible processes? Imagine you drop a hot cup of coffee on the table. The heat spreads out and cools down, but it doesn't go back to being hot again. This is a simple example of how entropy increases during an irreversible process. Entropy is a way to measure how disorganized or spread out energy becomes in a system. When things happen naturally, like heat flowing from hot to cold, the disorder increases. These processes are called irreversible because they can't be undone without extra effort. In real life, many factors cause entropy to grow. Friction is a big one. When two surfaces rub together, mechanical energy turns into heat, making everything more disordered. Heat transfer across a temperature difference also increases entropy. Heat naturally moves from hot to cold, spreading energy out and reducing its concentration. Mixing substances is another example. When two different liquids or gases combine, their molecules become more randomly distributed. This randomness means higher entropy. Chemical reactions also produce entropy because molecules rearrange and energy disperses. During an irreversible process, energy changes form. Some energy becomes waste heat that can't be used to do work anymore. That's why engines and machines always generate some entropy. The more entropy they produce, the less efficient they are. Mathematically, the change in entropy during an irreversible process is always greater than it would be if the process were reversible. If no heat is exchanged with the surroundings, any increase in entropy comes only from internal irreversibilities. Understanding how entropy is generated helps engineers improve systems. They try to reduce waste and make processes more efficient by limiting entropy production. Although perfect reversibility is impossible, minimizing entropy growth is a goal for better energy use. In simple terms, entropy is generated during irreversible processes because energy disperses spontaneously and molecules become more disorganized. This natural trend shows that real-world changes tend to move toward more disorder, setting limits on how efficiently energy can be transformed or used.